All right, so again, we're going over homework 1.6. We have number 13. We are showing that these are inverses. And to show their inverses, I use Fogg and Goff, right? I plug one function into the other, and if everything cancels out, we get x. That should be what happens. So f of x was negative square root x minus 8, and g of x was 8 plus x squared. 8 plus x squared. So we want to show their inverses, and we want to use this Fogg and Goff. So let's test it, right? Here's my test. F of g of x. Excuse me. So I'm going to start with the Fogg. I'm going to start with the f outside, g inside. So I'm going to write my f function first. Negative square root. I'm going to leave a bunch of space for the x here, because in that x, that's where g is going to go. Minus 8. I've got 8 plus x squared. Right? This part right here is g, and the whole outer function is f. Okay? X less than or equal to 0. Okay. So the way to do this, we're going to cancel some things out. First step, we see that these parentheses are unnecessary. We're not distributing anything. We don't need those parentheses. And therefore, this 8 and minus 8 cancel out. So we've got, this is negative square root of x squared. Yeah? Negative square root of x squared. I see. So when we do the square root of x squared, oh, goodness gracious. People coming in. Slightly tardy. All right, again, when we have the so we're doing the square root of x squared. Again, we're trying to cancel things. Here I know that my square and the square root will cancel out. Square and the square root are going to cancel out. Square and square root cancel out. And therefore, I've got negative x. The negative sign doesn't just go away. Right? Negative sign doesn't go away. So that's negative x. Is that what I need? Is that what I wanted? I don't think I wanted negative x. I think I wanted just positive x. Yeah, I don't think this is going to work, everybody. This, not inverse. So we know it doesn't work. Let's just, for posterity's sake, let's check the other one. Let's do g of f of x. Just so we know, we can see the whole picture. We know it's not an inverse, but let's do this part anyway, just to show you how to do this part. So I'm going to do my g in the outside, f on the inside. So I've got 8 plus x squared, and I'll leave a space, because in that x is going to be my negative square root x minus 8. Right? Now here's my g, my f. This here is f of x on the inside. And again, we're looking for things to cancel. How do we simplify this problem? I've got a square root, the square root here, and I have the whole thing being squared. So I know that when I square a square root, it's going to cancel. But how does this negative affect things? How does that negative affect things? Well, we can think of this, remember our rule, whenever we have something squared, it means there are two of them. So negative squared means I have negative square root of x minus 8 times negative square root of x minus 8. Squared means two of them. Don't kill puppies, everybody. I like puppies. I need them alive. Squared means two of them multiplied. So we have a negative square root times a negative square root. What happens when we multiply a negative times a negative, everybody? Negative times a negative, that's going to makes it positive. Two negatives times each other makes it positive. So when I square the negative, not only is my square root going to go away, but my negative becomes a positive, which is a very sort of important feature of this situation. So you got to be aware of everything that's going on when you have your situations here. Negative times a negative makes a positive. When I have these negative square roots, they multiply, they become a positive square root. So what am I going to have here? 8 plus, the negative went away, the square root went away, x minus 8. So again, I have an 8 minus 8. Those are going to cancel. And I'm just left with x. And that one works out. That's okay. But the other one didn't. And this is why it's important to check both directions. Important to check both directions. Okay? In the side of the problem, it says x less than equal to 0. It says this next to the problem. And that's just a domain restriction. And that's because of the square root. It doesn't change what we do at all. It doesn't change what we do. It just makes us look at a certain part of the problem. But either way, we have to equal x. And we don't. Right? We don't equal x by itself. One side is negative x, and that means it doesn't work. So the domain part doesn't change the problem at all. It just makes us look at a certain direction of the equation. We still need to be equal to x. We still need to be equal to x. Okay. All right, I got a request for a number 23. So let's try that one. 23. The graphing ones. Okay, so we got a bunch of graphs here. Let's see if I can draw these. A, B, graphs. More room here. C, and D. So my first graphs, actually these are a little bit different. What we're looking for here is looking at these pictures and trying to identify which one is the inverse of our function, A, B, C, or D. C, D. So with part A, it looks like this. We have an exponential going like that. In part B, we have graph coming down like this. C looks like it's kind of going here. And D looks like it's kind of wiggling like that. So those are our graphs. We want to match the inverse with the one we have. This is 23. So the graph of 23 looks like that. So which one is the inverse of 23? To figure it out, what you have to imagine is swapping the x and y points. Really what you're doing is imagine a mirror going along this line. Imagine a mirror. Yeah, flip the points, imagine a mirror, right? It's like you're folding it in half, butterfly, but like diagonal, a diagonal butterfly. And so you need to, like, each point has to match another point across the line from it. So if we're here, that means our mirror point's going to be here. Here we stay the same. Here, go down to here. To here. Here we stay the same. Here we go over to here. Right? You're just going across the line, finding all the points across the line. So this is going to be all along the line here. And then we go like this across the line. And then we go like this. Right, so you see all the points along this stuff here. It's going to look like that. It's like a DNA. Yeah, Ricardo, that's A. Good job. Like a butterfly. I'm like a bird, I want to fly away. It's like a butterfly here. So that's how you would do these problems. If you have a graph, better on a piece of paper, you can fold it and really trace along and see what's happening. You're looking at the mirror image of what's going on, flipping the points left to right across the line y equals x. Right, this red line is the point, is the line y equals x. That's where you flip these inverses across this horizontal, well, diagonal line. All right, questions about that? Imagine that flipping. All right, what else did we ask for? 68. 68. Is this one of our graph ones? I think it was. 68. Oh, I wanted you to find the inverse. Right, okay, I like this one. So, find the inverse. Remember, inverse is that's -1. 68 says find the inverse. And the function we have is, oh goodness gracious, is 6 over square root x. So to find the inverse, the way we do this is we swap x and y, and then solve for y. So we're going to make like a new equation. We want our inverse equation. We take our old equation, swap the x and y, and then resolve the equation back to y equals. So if we start with this as like y equals 6 over root x, my swapped equation is going to be x equals 6 over square root y. And we have to get the y by itself now. Have to get the y by itself. Okay? So how do we get the y by itself? It's on the bottom of a fraction. We have to know all the tools we have for rearranging equations. One of the tools we have is if we have something on the denominator, we can move it to the numerator by multiplying both sides. So I just multiply both sides by radical y. I want to move it from the bottom to the top. So I just multiply both sides, and I'm going to get radical y times x equals 6. Now I want to move this x to the other side. And the way I do that, it's multiplying. I cancel it by dividing by x. Dividing by x. Cancels my x. So I've got square root y equals 6 over x. And so a trick that you can see is to jump directly from here to here is just swap fraction. Right? You see the radical y is on the bottom and the x is on the top. Just take them and flip them. Take them and flip them. That's what's going to happen. A little trick you can do. Or you can go step by step, see what the steps are, figure it out. Last thing I need is to cancel the squared part, the square root part. Cancel the radical, and I do that. Remember, the opposite of a square root is squaring both sides. And when I square, I need to square the whole thing. That means this 6 is also going to be squared. That 6 is also going to be squared. So the 2 and the square root cancel. I have y by itself, and it's going to be 36 over x squared. And so my inverse, hold on, over x squared. So my inverse means f inverse of x, is equal to 36 over x squared. And that's my answer. Little tricks about manipulating these equations. When you have fractions like that, that little swapping trick, you'll see that happens a lot. Knowing these rules, being fluent in flipping these, in solving and rearranging equations is going to be extremely important for this class. Don't feel like you're fluent yet, do some kind of, I don't know, practice, do some kind of, watch some videos. I would love to help you, but I'm far away. But ask me questions, send me pictures on Schoology or on Remind. I'm happy to help. I've helped lots of people on Remind. I've gotten pretty good at explaining things. So if you're stuck somewhere, don't just stop. Ask me a question, send me a picture, I will send you pictures, we can work it out. Okay? But keep going. Keep trying. Put your pen to paper and give it a shot. And let me know if I can help. Okay? All right, that was inverses. Hopefully that helps remind you of things. Let's get into right now. What I want to do is go over what's going to be on the quiz, give you your review assignment, and answer any questions about any of the other topics. Okay. So let me go over that. Let me start a new page here. Oh, there's also questions about 1.5. You know, hold on. There's also questions about 1.5. I'm glad I wrote that down. 1.5. Who has a question about that one? That one is about the fog and Goff and function composition and operations. Adding, subtracting, right? F plus x, or f plus g, f minus g, f times g, and f over g. I saw there were some questions about that. Who had a question about that? No questions about it? All right, we're going to go over this again, like I said during the review. Just wanted to see if there was a particular question. All right, some of the questions also had to do with f of g or g of f, and also find equations for inverses. So I'll just, here, number 66 was asked about. Let me do this one together. So one example is we have an equation h of x, which is 1 minus x to the third power. And the question is, how do I, if this is the combination, if this is an f of g or a g of f, how do I look at this equation and figure out what part is f and what part is g? How do I look at this equation and find out what the outside function is and what an inside function is? And this is just looking at the structure of a problem, right? If you see the whole outside is this something cubed. Cubed is the outside, that's the thing that's happening on the outside. So we can imagine that f of x, this outside function, is something cubed. We call it x, but that's the package. X being cubed, that's like the outside function. And inside we have this little 1 minus x piece. That's kind of like stuffed inside this cubed piece. Right? You see you have an outside function and this inside function. And that's what we can call g. G of x could be 1 minus x. And there you see now, if we were to do f of g of x, or f of g of x, like that, we see that this g function, 1 minus x, would get put inside the x part, and then that whole thing is cubed. And that's how you can see how these functions work together. See how these functions create this, this structure, this composition of two things sort of inside each other. Okay. So this is definitely going to be on the quiz. Make sure you know how to recognize these and do those. I'm going to give you some practice with this as well for your review. All right, let's dive into that review. Let me show you how to do this. So this is Chapter 1 review. Oh goodness, let me do it in black. Chapter 1 review. Quiz topics. So things that will be on the quiz on Friday. I had a list here. Here we go. You will need to know how to, using points and lines, you'll need to know how to find equations of lines using y equals mx plus b, using slope, finding the slope of equations. You'll need to find equations of lines, solving these, or you can use y minus y1 equals mx minus x1, right? You'll need to know how to find the equation of a line, given some information of a point and a slope, or 2 points. All these different situations where you'll have to find equations of lines. Okay? You have to find the slope, you have to find equations, things like that. So lines and slopes, you'll need to know those. Lines and slopes. Topic number 1. Second thing is all about functions. You'll need to know the definition of a function. Is something a function, yes or no? Is something a function given a picture of a graph, given a picture of a table, given a list of points? Tell me if it's a function. Tell me if it's a function. Definition. What is a function? How do we know? You'll need to do the function operations. That means doing things like f plus g, f minus g, f times g, and f over g. And for f over g, you'll have to remember about the domain. Right? Where the bottom part cannot equal 0. You'll need to know about domain and range. Domain and range. The brackets or inequality version of how to define domain range. Try to do a little bit better here. Where g of x cannot equal 0 on the domain. So you have to tell me whether something is a function or not, using the definition. Operations, add, subtract, multiply, divide functions. You'll also have to find the domain range of things. I also am going to want you to do composition. Composition of functions. That's f of g, or fog, right, and goff. And goff, g of f. Also, for functions, you will need to know how to find inverses. Right, you should use f of g should be equal to x, right? It all cancels out. All cancels out. Or, of course, how to find an inverse. Find, too low. Find inverses by swapping x and y and solve for y. Find inverses by you swap x and y, and then you solve for y. Last thing you're going to need to know with the operations and with domain and with composition, I want you to remember how to plug into functions. If you see something like f plus g of 2, this means you plug in 2 to the g and to the f, right? It's not a multiply. You're not multiplying by this parenthesis 2. It means you're plugging in. You're plugging in these equations into this function, f and g, and then you're adding the result, you're getting a number. So make sure you remember, identify that plugging in. What else was there? Some graphs. Make sure you are aware of the graphs of these equations. After 2, plug into 2x. Plug into 2x. Why is it green? Oh well, whatever. Try green. Plug into 2x. So these main two things, right? These are our two big topics. Lines, slopes and lines. Make sure you know how to find the equation of a line. Make sure you know how to find the slope of a line. Y equals mx plus b, point slope form, all of that. And make sure you know how to deal with functions, the definition of a function, operations, plugging in, find the domain range of graphs, using composition and inverses of functions. How to find inverses, how to test for inverses. This is all what we talked about in chapter number 1. Chapter 1. Anything in particular that anyone wants me to go over? We have about 20 minutes, maybe 10 minutes, 10, 15 minutes. Anything that anyone wants a refresher on? List the topics you want refreshers on. Type in the chat anything you want me to kind of do a couple examples of, remind you about. Lines and slopes, first one. I figured that would be a popular one. Yes, fine, we can do that. Okay, lines and slopes, sure. Do an example about that. Anything about functions? Feeling uncertain? Anyone feeling uncertain about how to do a particular piece of this? Domain range, sure. Let me just sort of put next to here on domain range. There are only two ways to restrict domain. Two restrictions. Not maybe 2 ways, 2 restrictions. There's only 2 kinds of restrictions for the domain, right? 2 restrictions. Restrict. Goodness gracious. That says restrictions, everybody. Restrictions. The first, for domain range, the first type of restriction is when you have x on the bottom. Bottom of a fraction. And that cannot equal 0. Not allowed to equal 0. That was our restriction, the first type of restriction where we have a fraction. Second type of restriction for the domain range is a square root. And the restriction for that is that x has to be greater than or equal to 0. Those are our two restrictions for domain range. So I'll go over an example there. Anything else? Domain range. I'm feeling like I'm just not sure about how to do a particular topic. Feeling a little uncertain about something. Part of the homework that you were just like, I hope I don't see a question about that on the test. We're feeling okay? We know how to define functions, plug in inverses, we know how to find, well, we'll do an example about slope. All right, let me do these examples then. First one, yeah, first one for sure. So let's talk about lines. So if I asked you, for example, find the equation of a line through the points 1, 3 and -2, 9. Find an equation of a line through those 2 points. What do we do? Find the equation of a line through these points. 1, 3 and -2, 9. I'm looking for an equation. Keyword. If I say equation, what I'm looking for is y equals mx plus b. Equation means y equals mx plus b. If I want an equation, I need to find 2 things. I need to find the slope, and I need the b. I need m, and I need b. So we've got to find those 2 things, given this information. We remember, hopefully, to find the slope is the slope formula y2 minus y1 rise over run over x2 minus x1. Your slope formula, right, we'll find our slope and the intercept. Slope formula, use this slope formula. Find the distance between these points, right? y2 minus y1, start with the 9 minus 3. 9 minus 3 over -2 minus 1. Over x2 minus x1. Nine minus 3 is 6. -2 over -1 is -3. 6 over -3 is -2. -2. This is m. So you find your slope. So we found our slope. Now, how do we use that to find b? There's a couple ways you can do this. I want to show you what I think is the easiest way. To find b, use a point. You're going to use one of these. B always comes from one of these specific points that you plug in to get to get the y-intercept out. So we're going to use one of those points to write our equation, right? We have y equals mx plus b. So I have the negative 2. Y equals negative 2x plus b. Right, so I use my negative 2. I use my slope. And then I'm going to pick one of these. I'm going to pick, I like the positive one. I'm going to pick this one and plug that into my x and y. So I'm going to get 3 equals negative 2 times 1 plus b. Plug in the point. Yeah? And then you just solve for b. 3 equals negative 2 plus b. I'm going to add 2 to both sides. And I've got, so far down. Yeah, either point is going to be just fine. B equals 5. No matter which point I used, the answer will be 5. No matter if I use the first one or second one, they're both going to make my answer 5. So I've got b is 5. I use those now. Y equals negative 2x plus 5. And there's your answer. Plug the b, plug the m, get your equation. That's your formula. Finding slopes, finding equations. So for m, use the formula. For b, use a point. You can use either one. Either point is fine. They'll both give you the same answer. B will be 5 no matter what you pick. I picked the one that was positive because, I don't know, I like positive. I'm a positive person, everybody. What do you want from me? All right. So that was lines. That's the basic of what you're going to need to do, right? Find the equation, find your line. The other one was domain range, right? Domain range. Okay. I'm going to ask you to find the domain and range, maybe restrictions. Find domain and range of function. If I say f of x equals, let's say, 2x minus 1 over 3x plus 5. What is the domain and range of this function? Looking for the domain, we are looking for the domain restrictions. I want to know the domain restrictions. I want to know what is not allowed. Are there any restrictions for this equation? What do you think? Do I have any domain restrictions? Remember, our default is all real numbers. But two things give us restrictions. Does this function have a restriction? Edward says yes. What's the restriction, Edward? What restriction do I have? Yeah, the bottom part here is not allowed to be 0. Good. So I have a restriction. I need to list that restriction. I need to explain what my restriction is for this domain. So I will say that 3x plus 5 is not allowed to be 0. And then I have to solve. I have to solve this and get x by itself. Get x alone. Solve. Get x alone. So I'm going to do that. I'm going to minus 5 on both sides. You're just solving like in a regular equation. 3x is not allowed to be negative 5. Okay, then I have to divide by 3, get x by itself. X is not allowed to be negative 5 over 3. There's my restriction. X is not allowed to be negative 5 over 3. So that's the domain restriction, right? And so I will ask you to find one of those. Make sure you know the two restrictions. What else might I ask? Maybe you're going to have a graph. Maybe you have a graph that looks like this, perhaps. And I want you to tell me, find the domain and range. What would the domain and range be of this kind of graph? Well, this is what we talked about with the brackets and the inequalities, right? So you take it one piece at a time, you look at the domain, you look at the range, right? Domain, remember, is all of the x values. Range is all the y values. So let's look at the domain. All the x values. What's the x values of this equation? Are there any restrictions? Remember, we're looking for a box. We're looking for a sandwich. Try to create our domain and range sandwich. Domain range sandwich. What are the limitations on the domain and range? Well, looking at the graph, we see it goes forever to the left. That's the arrow. And the arrow also shows arrow forever to the left. Also, it says arrow forever to the right. So our graph goes forever in every direction. So what's the domain going to be? Infinity both ways. Yeah, we can write this a few ways, right? We said one of the ways we said we could write it like parenthesis negative infinity to positive infinity. And remember, parenthesis because we don't actually reach infinity. Or you can use that double bar R, all real numbers. What about the range? Range is y. Looking at the up and down, we see there's some kind of limitation on the height of our function. Down, it goes down forever. But if we're looking up and down now, range is looking up and down, we hit a ceiling, right? We have a sandwich for our function sandwich. There's a top half, but there's no bottom half of our sandwich. So bottom half means forever down here, infinity down here. But this limitation here looks to be at, it's at 4 actually, everyone. 1, 2, 3, 4. Looks to be at 4. So how would I write the domain range here? How would I write the range? I could do parentheses. So I know that I go low first, so I'm starting negative infinity. and I go up to 4, and I put a bracket. Is that right? Bracket? Carter says no. No bracket. What should I put instead of a bracket? Bracket means, yeah, there's an asymptote there, right? So it doesn't actually reach the 4. Very good. There is an asymptote. It does not actually touch 4. Bracket means it touches. Parenthesis means it does not. If you wrote a bracket on the test, the question would be wrong. I'd give you partial credit if you got the 4, but you would lose points for putting the bracket instead of a parenthesis. Make sure you use the right symbols. For the range, we could also do the inequality version. We could say y is everything that is less than 4. Not equal to, right? Not equal to, because we don't actually reach it. No equal to. Just less than 4. Same idea. Great. Any questions about that? Or any other situations that are weird that people want to think about and ask about? What if, Mr. Mitchell, what if this happens? What about? Unmute yourself and ask. Type it in the chat. I don't get it when no? We're feeling okay. All right, what I'm going to do, we're just about out of time. What I'm going to do is I'm going to give you your review assignment, and I'm going to explain what I want you to do for this assignment. So, review assignment. It's a lot of questions, but I don't need you to do all of them. It's, where'd it go? Page 83. Page 83. Numbers, and again, I'll put this up on Schoology. 19 to 22 all. Hold on. 19 to 22, 35 to 39 all. 43, 45, 47, 48, and then 101 to 106, 115, odd, and then 123, 124, 129 to 134 all. Whoa my gosh. That's a lot of it. How many questions is that? 19, 20, 21, 22, that's 4. 4 questions. 35, 36, 39, 5 questions. 1, 2, 3, 4 questions there. 101, 3, 5, 7, 9, 11, 13, 15. That's 8 questions there. 9, 10. Let's see. 39, 30, 31, 32, 33, 34, 6, 7, 8 questions there. No, you are not required to do all of them. 4, 9, 13 plus 16 is 13 and 16 is 29 questions. Call it 30. So 30 questions. Of these 30 questions, you must do 15. Half the questions. You only need to do half of them. I want 15 questions. You can pick whichever ones you want. Whichever 15 questions you want to do those 15. It is due Friday, day of our quiz. Okay, everybody? 15 questions. Do the day of our quiz. I see we're out of time. I'll put this up on Schoology. Thank you, everybody, for reviewing with me. Type goodbye in the chat. When you type goodbye in the chat, you're free to go. Have a great day. I will see you Friday. Study and practice. Thank you, everybody.